Hey everyone, it's Jake Hall, the Manufacturing Millennial. We are here in Scranton, Pennsylvania, and I am with PSA Systems, a custom automation machine builder that does a lot more than custom automation equipment, as I found out through touring the facility today. So I'm here with Mike McHale, he's the CEO. We have Danny Likens, who is electromechanical engineer, and then of course Nick Rosati, who's a defense program manager. So I had this idea when I was walking in this facility of what custom automation defense contracting would look like in that area, and specifically this conversation we'll be talking about the work that you do with the DoD. So I guess to start off with, how did you guys get started with the DoD? And then we're going to get into this drone that's sitting on this table a little bit, but how did PSA get involved with government contract work?
Geez, about 12 years ago now, we were working with some people. They needed some springs made, and we had a guy in the shop. He was talking to the customer, and as he was talking with the customer, he goes in the back and makes the springs, comes back, and the customer is blown out of the water and just extremely happy about these little springs. And it led into us doing more R&D work, a lot of stuff with different drones back then, and it just kind of kept growing more and more. We started doing machining, making prototype rounds, and then eventually getting into stuff like this.
And I think that was one thing you mentioned about drones, and we talked about air. So I think, like, if we were to classify like what I walked through the floor today, and Mike didn't even think about this, which I'm kind of proud to come up with this. It's PSA really covers land, sea, and air when it comes to product developments that you're doing with the DoD. And we'll start with the air because that's what's in front of us here. So when it comes to surveillance over territories that we want to look at, there's the satellites, which are very hard to move, very expensive. They're very, there's a big investment and not really accessible to get real-time information. Then you have the UAV level, right, which is one of those things where you have to fly into a territory to get classic information. Then what has become really popular over the past few years with current events has been this idea of drones for better surveillance. Now, you guys have been doing this for years before the whole Ukraine.
10 years we've been developing the UAVs.
So you've had a big foresight. But in terms is, you created a UAV that can get shot out of a device at a very, very high G. And then basically as that gets separated, it gets close to the position, it will unfold. Yeah. And then it would create where then a operator could fly that drone around to then get surveillance or deliver stuff or do additional information.
Yeah, that covers pretty much what we've done. Just the special sauce here at PSA is that the normal drones and UAVs you see on the shelf don't fit the applications that our customer would need. Where in this case, if you need to fit in a tube to be able to launch, you need to have your arm be able to fold. Yeah. And your propellers need to fold, and you have to have strong custom carbon fiber propellers, and you need your electronics to be custom fit to the airframe because it's such a unique design. So we have to develop our own boards and develop our own technology to go along with all the different stuff goes into these high-end UAVs.
So I think to put it in perspective, right, when you're going off and you're going on a roller coaster, you're experiencing what? 1, 2.
And when I did Roller Coaster Tycoon back in the day, the customers would complain at like 6. Yeah. So like
1 to 2 G. A fighter pilot might experience 5, 6, 7, 8, 9 Gs. Yeah. A NASA astronaut might experience, I forgot what their max G.
Oh, it's a lot.
It's like 20.
It makes them black out sometimes, so you gotta be careful.
But then when we're talking about firing out of a device, we're talking hundreds, if not thousands of Gs. Tens of thousands of Gs. And I think a lot of times when it comes to all these components have to work together to make it happen. So that's kind of what you're doing here. Now, this is a device that we can share. This isn't the device that obviously that you guys are fabricating that we were able to look at one of the facilities. But the whole idea is you're fabricating and designing the PCB boards. You're doing the springs, and pretty much everything you're custom fabricating in order to make it so it can withstand this very high G-shock load.
Because, just to put it in perspective, if a motor weighs 100 grams and it experienced 10,000 Gs, now it weighs kilograms upon kilograms for that split second. And it's a good way to help visualize. Imagine this little arm
Yeah.
needing to support something that's currently weighing 100 kilograms.
So to not go away from this, but Mike, I want to bounce a question off to you. When you're the CEO of here at PSA Systems, what is it like when you walk into your facility in the morning, and we walk over here and you're having a robot cell that's doing candy assembly and doing that. There's a Hummer behind us. Behind us here, there's some cutting and sleeving that's happening. We walked over to another area that you're making components that go on an aircraft carrier, to another one that's handling special, polymer materials. Do you ever sleep at night wondering, what am I in? What am I doing?
Many nights. Most nights.
You managed to sleep?
Most nights. But in reality, PSA, we really look at it in two ways. We use our engineering capabilities and we use our manufacturing capabilities and meld the two. So everything we do bases either off of engineering or manufacturing. And there's a component of both in everything we do. So it doesn't really feel that weird to us because everyone here is an engineer. So then we engineer something and we fabricate it and we deploy. So that's the base of what PSA is.
When it comes to the design process and the iterations, right? You have a lot of different iterations that come through here. How do you as a company manage, I guess you could say, the constantly changing environment of new technology and customer demands and changes over time? How do you manage that as a mindset?
Iterative design is one of my it's one of my favorite things, and I've heard it said before, fail fast. You'd have to obviously plan what you're doing in advance to know if something, you do your best, put your best foot forward, but try something, see how it's going to come together, and then once you see whether it's functioning the way you wanted it to or not functioning, learn and apply what you've learned into the next generation.
We have a great team of engineers that are really into basically everything that we do. So when they're not here, they're at home, they're working on racing drones, they're looking into making their own electronics, they're up to speed on everything that's happening, and we get excited over there's this new chip that came out, this is awesome. And then that feeds into what we're doing, and we're lucky enough where we can come up with an idea, we go make it in the shop real quick. Sometimes it's the same day we can go from idea to testing something and able to iterate fast, and that really helps us out.
And I think that adds on to, and I think we'll probably talk about that in another conversation, Mike, but how when you're able to empower people's passions and turn their passions into opportunities, I think that's really where exciting things happen. So you talked about your drone pilot, for example, right? So while he's doing testing for this, he's on the weekends, he's flying drones competitively.
Yeah, and he's winning competitions.
And he's winning competitions. Yeah. So Mike, how do you, as a leader, mindset perspective, make sure you see the passion that your employees have, but then you take those passions and you turn those passions into opportunities where they feel like they can, that the employee feels now invested and empowered to do what they do to do what they love while at work?
Yeah, well, I think the first thing is they started doing what they wanted to do right from the get-go, and we have a culture of allowing our staff to kind of grow and think about new things and not stifle that invention. So you can invent something here and then roll it out to the shop. Since we are vertically integrated, that helps the idea flow fast. Mm-hmm. You can flow the idea fast. You can modify it fast and play with it. And honestly, a lot of the innovation that has happened here has happened probably with staff at home thinking about things and coming in the next day and deploying. And we have a fun work environment and we work on cool things. Not too many facilities in the country you can come and work on a drone and the same day play with a robot.
Yeah, absolutely. So what would you say, what are things that leaders could do a better job of when it comes to creating that culture and that mentality?
I really think it comes down to, as a leader, you don't want to overthink and you don't want to overlead. If you overlead, that stifles the innovation. Mm-hmm. And the culture here of everyone is a steward of PSA. It might be my company, but I'm not the steward of the entire company. Every single employee, Danny, Nick, yourself you're now a steward of the company. Mm-hmm. And if you're not passionate about what we do, then maybe we're not the right place to work. You can go find another job, and I'm sure there's somebody else that wants to come in and be passionate about what we do.
Yeah. and I think that's one of those things is when I walked in and I saw, Nick and Danny, your workstation, right? You have a PSA, Skunk
PSA
Works,
Skunk Works.
Which if you're not part of the whole military nerdism of the community, Skunk Works was a program that was developed back in was it the 60s?
Something like
is
that.
when
It's-
Kelly
yeah.
Kelly Johnson, one of probably the most brilliant engineers of all time, helped build out the stealth program and the high speed program through Lockheed Martin. Built out this group of just super passionate people to create amazing devices and technology. And when you brand yourself internally and you have this internal joke system, it just shows that it's a culture, right? And it's a culture of opportunity, fun, but it's also the mindset of, hey, we're going to do some really cool stuff. And you feel though, as with when you look up and you see your management above you and your leaders above you, it's a place that's an accepting mentality of that.
Like you said, the culture is everything, because it's a culture where you can come in, you build something, you try something. No one's scared of oh, what if I do this wrong? It's no, it's accepting, let's all work together and try to make some cool stuff happen, and everyone's excited to make cool stuff happen. So.
To be honest, I mean, these type of programs are programs devised out of failure. You're never going to make the first one and it's going to do what you need to do, so you're going to fail 50 times till you get it right. The problem, the issues that our guys have is we try to deploy these programs from start to finish in 6 months. So we'll come up with a concept and in 6 months deploy. New circuit boards, new software, new engineering, and that's obviously a lot faster than most government entities.
When I flew into Scranton, Pennsylvania this morning, when you fly in on American Airlines, you're flying over a coal refinery, plant. And I think for so long, Pennsylvania was thought of as the coal and the steel industry of the U.S., where it was that dirty place. And I think that a lot of times that's what we think of as just traditional manufacturing in a lot of cases. And so now we look at it as there's a lot of really unique defense contracting that's going on here. Some of the stuff we can't talk about that you guys are manufacturing with inside of here. But then all of a sudden, how does that affect the new generation who thought growing up in a region where everything would have been either gravel pits or coal mines or, dirty things, but all of a sudden, no, we're here building drones that can get launched at, several hundred Gs. How does that affect this young generation's mindset?
Well, I mean, even I'm 31. I'm even starting to age out of the young generation. Yeah. But talking to high school robotics teams and people, the mindset has been shifting for the last couple of years, where it was a time where everyone wants to move away and go to the great land of opportunity wherever they think it might be, and then sometimes people get there and they realize it's the world's the world. The opportunity exists everywhere.
You look at the three of us. I grew up 800 yards from where we're sitting. Nick grew up 3 miles.
Yeah, I'm the transplant a whole hour and a half away.
Danny's an hour and a half. So when you look at the three of us, Nick and Danny both went to Wilkes locally here in the area, and the idea of changing the old coal type communities into technology, it's here.
Yeah,
and we're changing it.
We're going to Lackawanna College tomorrow. And we're going to go meet with Wolfpack Robotics, who is a local high school team. Have either of you guys interacted with those high school teams before? Or
I actually am now a mentor on their team as of last week.
What's it like them being as a person who has a massive aspiration and passion for this type of technology? Obviously, you're flying a drone that goes hundreds of feet per second and up in the air, zipping around, where they're driving a robot that's on the floor. But how can you use this then to inspire that next generation to be in your shoes 10 years from now?
They're especially young minds that are just passionate about stuff. They almost don't want to turn off. So when you give them the carrot on a stick almost to dive towards, of you're working on a robot right now that someone helped you buy these parts. Here's a controller. Here's how you do some simple code, and then you get to see what it can turn into, and you dangle you're working on this now, and it's just really cool now. But also if you stay on this path, you can work on what this is, and technology's moving so quick. you can be the one that's defining the cutting edge of technology. And you tell that to someone that's like 16 and just like excited about everything. And like, if I like focus and work, I can be the one defining the cutting edge, and like nothing's going to inspire someone more than that.
Yeah, Mike, what would you say as you know, when you are talking about all the land, sea, air aspects of PSA? You know, how do you see? And we could talk more about that maybe in an upcoming conversation with Matt. But like, how do you see that as an impact for future generations when you're able to touch all these different types of manufacturing opportunities that exist that get young kids excited about this?
Well, I really think locally here at PSA, these are just the start, right? So this is the start of the growth of the tech innovation we're trying to do. So, you know, we're right now working on a payload that's going to go to the ISS that Nick's working on right now. So in the next year, we're going to be sending something to the ISS.
We're going to
space. Growing, and we're going to be growing that portion of our business out and doing more. And that's going to feed into more government programs and more technology and more robotics. So this is just the beginning.
That's awesome. That's awesome. Well, Mike, Nick, Danny, thanks so much for your time. I really appreciate it. Love you guys' passion that you're sharing, and I hope I never see one of these in person.
Yeah. Besides on a desk.
Besides on a desk, but thank you guys for sharing your stories. I really appreciate it.
Absolutely. Thank you.
Awesome. We'll see you guys soon.